Previously, we discussed about using samples to gain insights into the population. However, if the sample is not representative, then your result is not trustworthy. How do we know if our sample is representative or not? In this section, we are going to introduce inferential statistics. So far, we have learned to use descriptive statistics such as mean and standard deviation of samples to summarize the characteristics of the population. Inferential statistics verifies whether the sample is truly representative of the population. Hypothesis testing is a common form of statistical inference. This slide reviews some of the terms that form the basis of statistical inference, as introduced in previous lectures. Make sure that you understand these basics before proceeding. We'll get familiar with the hypothesis testing in this lecture. A confidence interval or a degree of certainty is placed around the sample statistics to state that the sample statistics is within a certain range of the population parameter, such as mean. Hypothesis testing is also called significance testing. It tests whether a sample statistic is representative of or significantly different from its population's parameter. The parameter include population mean, total, and proportions. The procedure of the hypothesis testing follows 5 basic steps. These are the 5 basic steps. The first step is to state the null and alternate hypothesis. Then, select an appropriate statistical test and calculate test statistic. The third step is to select a level of significance. We usually use 0.05, but according to your research question or the context, you may set another significance level. The fourth step is to find critical value and compare to test statistics. And finally, you can interpret your finding based on these results and make a decision regarding the null and alternate hypotheses. And first, let's take a detailed look at the appropriate statistical tests that can be chosen from. We will focus on the one sample difference of mean test. Here, the parameter we are evaluating is the mean. Under different conditions, we choose different statistical tests. If we know that our population is a normal distribution, and we have prior knowledge about the population parameters such as mean and standard deviation, and the level of measurement is either interval or ratio, we can use z-test. However, if we don't know whether the data distribution is normal, or we don't know the population standard deviation, then we will opt for t-test. If the data is categorical, we can no longer use z-test or t-test. Instead, we may use chi-square test.